Aside from the anti-tail turning to a tail, which could have a natural origin, I actually wrote 2 scientific papers trying to explain it, but it's not a simple explanation because we don't know if there is dust at all around this object.
A new photo of 3I Atlas just came in from Italy, captured December 15th by astronomer Toni Scarmato. It shows something that shouldn't be possible. The antitail grew to 500,000 kilometers. That's bigger than the distance from Earth to the Moon, the largest antitail ever observed for any comet. Here's the problem. It grew this big in 45 days, after the comet passed the Sun, when it should have been shrinking. And the physics don't work. Material is moving toward the Sun at 130 meters per second, against solar wind, against radiation pressure. That's not how comets behave, and scientists have two very different explanations. Toni Scarmato operates an observatory in Calabria, that's in southern Italy. On December the 15th, he pointed his telescope at 3I Atlas, took a 60-second exposure, combined it with other frames, applied a filter to enhance contrast, and the result is stunning. The image shows the comet as a bright central point. That's the nucleus, the core, and extending from it toward the Sun is a massive structure, the anti-tail, glowing, defined, stretching across the field of view. The processed image uses false colors. Red shows lower brightness, green and blue show higher brightness, and the anti-tail lights up in green and blue. Bright, active, enormous. The field of view in this image covers about 860,000 kilometers by 390,000 kilometers. At the distance 3I Atlas is from Earth right now, and the anti-tail extends across most of that field. 500,000 kilometers from the nucleus toward the Sun. Let's put that in human terms. The Moon orbits Earth at an average distance of 384,400 kilometers. That number varies. The Moon's orbit is elliptical. At its closest, it's about 363,000 kilometers away. At its farthest, about 405,000 kilometers. The anti-tail of 3I Atlas is 500,000 kilometers long. That's longer than the Moon ever gets from Earth. That's longer than the maximum distance. You could fit the entire Earth-Moon system inside the length of this anti-tail and still have room left over. Another way to think about it, Earth's diameter is about 12,700 kilometers. The anti-tail is 500,000 kilometers. That's 39 Earths lined up end to end. Or, if you prefer, the Sun's diameter is about 1.4 million kilometers. The anti-tail is more than a third the width of the Sun. For a comet nucleus that's maybe a few kilometers across, this is absurd. The nucleus is tiny. The anti-tail is enormous. The ratio is wrong, way wrong. And this is just what we can see. The anti-tail might extend even farther. The limit of what shows up in the image might not be the actual end of the structure. It might fade below detection, or extend beyond the field of view. 500,000 kilometers is the confirmed minimum. The actual length could be larger. This is unprecedented. No comet has ever shown an anti-tail this large, not even close. Normal anti-tails are perspective effects, temporary illusions that last a few days. You see them when Earth crosses the comet's orbital plane. The dust tail curves. From certain angles, part of it appears to point sunward. But it's just the viewing geometry. The tail is still physically pointing away from the Sun. You're just looking at it edge on. Those perspective anti-tails are short, a few thousand kilometers at most, and they disappear quickly as the viewing angle changes. 3I Atlas has had a sunward pointing structure for 5 months. July, August, September, October, November, December. It never went away. It's not a perspective effect. It's real material extending toward the Sun. And now it's grown to 500,000 kilometers. That's not a perspective trick. That's actual growth. actual expansion. The structure got bigger. Other telescopes confirm this, not just Toni Scarmato in Italy. Observers in California captured similar images on December 14th, a 14-inch telescope in June Lake. Over 2 hours of integration time, multiple exposures combined, processed to enhance faint details. Same result. Massive antitail extending sunward. The California images show the same structure, same orientation, same size. Independent confirmation from a completely different telescope, different observer, different processing software. But the data matches. Observers in Thailand imaged it on December 13th. A telescope in Rayong applied a rotational gradient filter. This type of filter is designed to highlight structures that don't match the typical brightness pattern of a comet. It makes asymmetric features stand out, and the antitail shows up clearly, pointing toward the sun. Persistent, large, unmistakable. Multiple independent observations, different telescopes, different locations, different equipment, different processing techniques, all showing the same thing. The antitail is real, it's massive, and it's growing. This is how science works. One observation could be an artifact, a processing error, a glitch in the camera. But when multiple observers in different countries see the same feature using different methods, it's real. The antitail exists. The size is confirmed. The growth is confirmed. Here's the physics problem. The comet reached perihelion on October 29th. That's the closest point to the Sun in its orbit, about 203 million kilometers, between the orbits of Earth and Mars. After perihelion, comets move away from the Sun. They get farther from the heat source. The solar heating decreases. Ice sublimation slows down. Activity drops. The coma shrinks. The tail fades. This is predictable. We've observed hundreds of comets. They all follow this pattern. Brightness peaks near perihelion. Then it decreases as the comet moves away. 3I Atlas reached perihelion on October the 29th. It's now December 15th. That's 45 days later. The comet has been moving away from the Sun this entire time, getting cooler, getting less solar energy. The antitail should be shrinking, fading, disappearing. Instead, it grew to 500,000 kilometers. To grow that much in 45 days, the material has to be moving fast, really fast, and in the wrong direction. Do the math. 500,000 kilometers in 45 days. That's about 11,000 kilometers per day. Divide by 24 hours. About 460 kilometers per hour. Divide by 60 minutes. About 7.7 kilometers per minute. Divide by 60 seconds. 130 meters per second. Minimum. That's the average speed the material needs to move sunward to create a 500,000 kilometer structure in 45 days. And that's assuming constant motion. If the speed varied, the peak speed would need to be higher. 130 meters per second doesn't sound that fast. It's about 290 miles per hour. A fast sports car, a Formula One race car at top speed. But this isn't a car on a road. This is dust and gas moving through space. And it's moving toward the Sun, against forces that should be pushing it the other direction. Let's talk about those forces. Solar radiation pressure. Sunlight carries momentum. When photons hit a particle, they push it. The pressure is small, but in the vacuum of space, it adds up. For small particles, radiation pressure is stronger than the Sun's gravity. It pushes them away from the Sun. Think of it like wind, except instead of air molecules, it's photons, light particles. Each one carries a tiny amount of momentum. When a photon hits a dust grain and bounces off, it transfers that momentum, gives the grain a tiny push. One photon, negligible. 1 trillion photons per second, that adds up. The Sun is bright. It's constantly hammering every object in the solar system with light, and that light pushes. The smaller the particle, the stronger this effect. A dust grain 1 micrometer across has a lot of surface area relative to its mass. It catches a lot of photons, but it doesn't weigh much, so the push is strong. The grain accelerates outward, away from the sun. Dust grains smaller than a micrometer get pushed really hard. They accelerate outward at meters per second squared. They quickly reach high speeds, away from the sun. That's what creates a normal comet tail. Dust gets pushed outward, creates a tail pointing away from the sun. Larger particles don't get pushed as hard. A pebble has more mass. The same number of photons hits it, but the push is spread across more mass. The acceleration is smaller. Gravity wins. The pebble stays with the comet or falls back. There's a sweet spot. Particles that are just the right size to get pushed away, but not so small they evaporate. Those particles create the visible dust tail, and they always point away from the sun. Always. Solar wind. The sun constantly ejects charged particles. Protons. Electrons, plasma flowing outward at about 400 kilometers per second. When this plasma hits cometary gas, it pushes it, creates the ion tail, also pointing away from the sun. Both forces push material away from the sun. Both forces are strong. Radiation pressure for dust, solar wind for gas. Combined, they create the classic comet appearance. Tail pointing away from the sun. Always. 3I Atlas has material moving toward the sun at 130 meters per second against both forces. Something is pushing that material sunward. Something strong enough to overcome radiation pressure and solar wind. Strong enough to accelerate particles in the wrong direction. Strong enough to maintain that acceleration for 45 days. What could do that? There are two explanations on the table. One is natural but extreme. One is not natural at all. Explanation number 1, extreme natural process. Maybe this is still a comet, just doing something comets haven't been observed doing before, at least not at this scale. The idea is that ice pockets on the surface facing the sun are sublimating violently, releasing dust and gas. But instead of that material getting pushed away immediately, it hangs around, creates a cloud, reflects sunlight. And from Earth, that cloud looks like an anti-tail pointing toward the sun. For this to work, the particles need to be the right size. Too big, and they fall back to the comet. Too small, and radiation pressure pushes them away. But if they're just right, maybe they can linger, evaporate slowly, create a persistent glow. This has been proposed before, for smaller anti-tails on other comets. The particles are so small they sublimate before radiation pressure can push them very far. They evaporate in place, scatter sunlight, create a temporary glow. But 500,000 kilometers? For 45 days? That's way beyond what's been seen before. To maintain this, you need constant replenishment, new particles released all the time, replacing the ones that evaporate or drift away, and those particles need to be exactly the right size. And the sublimation needs to be perfectly aimed toward the sun, creating a collimated jet that extends for 500,000 kilometers. It's possible? Technically. Physics doesn't forbid it, but it requires conditions we've never observed. A very specific combination of factors, all working together perfectly, for weeks. And it doesn't explain the speed. Why would sublimating particles move sunward at 130 meters per second? What's accelerating them in that direction? Sublimation creates outward pressure, away from the surface, not toward the sun. Maybe there's a process we don't understand. Maybe something about interstellar comets is different. Maybe 3I Atlas has unusual composition that creates unusual behavior. But we're speculating, trying to fit observations to a natural explanation, stretching the physics to make it work. Explanation number 2, technological thruster. This is where it gets controversial. Avi Loeb published an article about the new images. He's a professor at Harvard, astrophysicist, former chair of the astronomy department. He runs the Galileo project, which searches for signs of extraterrestrial technology. In his article, he lays out the physics problem, the size, the speed, the persistence, and then he writes this. Whether this speed can be maintained by sublimated dust or gas from pockets of ice facing the solar wind and solar radiation pressure remains to be studied. The alternative is a jet from a technological thruster. A technological thruster, as in not natural, as in engineered, as in propulsion. This would explain the speed. Thrusters produce directed thrust. They can maintain constant acceleration. They can push exhaust in specific directions, and they can operate continuously as long as they have fuel or energy. If 3I Atlas has a thruster pointing backward along its direction of motion, the exhaust would trail behind, like a rocket, like a jet contrail. Except in space, there's no air, no wind, no turbulence. The exhaust just drifts, spreads out slowly, and keeps glowing as long as it's reflecting sunlight. And since the comet was moving toward the sun in July through October, that exhaust would extend sunward, creating what looks like an anti-tail. Not because the thrust is pointing toward the sun, but because the object is moving toward the sun and the exhaust trails behind. Think of it like a boat wake. The boat moves forward, the wake trails behind. From the front of the boat, the wake extends backward. Same principle. The thruster pushes forward. The exhaust extends backward. From our viewpoint, that backward direction was sunward for months. As the comet swings around the sun and starts moving away, the thruster exhaust would still trail behind. But now the direction changes. The comet is moving away from the sun. The exhaust still points backward, which now means it points away from the sun at a different angle, which matches observations. The anti-tail has been shifting orientation as the comet's trajectory curves. A thruster would also explain the size. Rocket exhaust can extend for huge distances in the vacuum of space. No air resistance, no friction, no drag. The exhaust particles just keep moving until something stops them, and in space, nothing stops them. They drift outward indefinitely. Look at satellites. When they fire thrusters, the exhaust plume can extend for kilometers, tens of kilometers, and those are small thrusters, low thrust. If you had a larger thruster operating continuously in the vacuum of interstellar space, the exhaust could accumulate over days and weeks. 500,000 kilometers of exhaust? That's unusual, but not impossible for a thruster that's been running for months. If it started in July and kept going through December, that's 5 months. The exhaust would spread out, disperse, but it would still reflect sunlight. And from Earth, we'd see it as a glowing trail. Loeb isn't saying this is a technological object. He's saying the physics demands an explanation. And technology is one possibility that fits the observations. The scientific community is divided. Most astronomers think 3I Atlas is a natural comet with unusual but still natural behavior. They point to the chemical composition. Webb detected carbon dioxide, water, carbon monoxide, standard comet volatiles. But Loeb argues those volatiles could come from surface ice, even on a technological object. If it's been traveling through interstellar space for billions of years, ice would accumulate. Micrometeorite impacts would embed water and organics. Cosmic dust would coat the surface. So detecting comet gases doesn't prove it's natural. It just proves there's ice on the surface, which you'd expect either way. The debate continues, and it won't be settled by images alone. There's a way to distinguish between these explanations. Spectroscopy. Spectroscopy measures the speed and composition of the jets. Natural sublimation produces gas at specific velocities, typically a few hundred meters per second, thermal speeds, based on the temperature and molecular mass of the gas. Technological thrust produces different velocities. Could be slower, could be faster, depends on the thruster design, but it wouldn't match thermal sublimation. Composition also matters. Natural sublimation releases whatever volatiles are in the ice. Water, carbon dioxide, methanol, hydrogen cyanide. The ratios depend on where the comet formed, what mix of chemicals was in its parent cloud. Technological exhaust could show different ratios, or unusual molecules, or isotopic signatures that don't match natural processes. These measurements can be made. Spectrographs on large telescopes can capture the light from the jets, break it into wavelengths, identify the molecules, measure their velocities. The comet is at its closest approach to Earth right now. This is the best observation window, the highest resolution, the strongest signal. If spectroscopy is going to answer this question, it needs to happen in the next few days. After that, the comet moves farther away. The signal gets weaker. The measurements get harder. By early next year, it'll be too faint for detailed spectroscopy. This is the moment. The window is open. The data will either support natural sublimation or it won't. And if it doesn't, we have a much bigger mystery on our hands. The Italian photo shows an anti-tail 500,000 kilometers long, bigger than the distance to the Moon, the largest ever observed. It grew to this size in 45 days, after perihelion, when it should have been shrinking, and the material is moving toward the Sun at 130 meters per second, against solar wind, against radiation pressure. Two explanations are on the table: extreme natural process, or technological thruster. The physics demands one or the other. Spectroscopy can tell us which. And the observations are happening now, while the comet is still close enough. Subscribe, because we'll cover what they find, whatever the data shows, whatever explanation the measurements support. The anti-tail just grew to impossible size, and we're about to find out why.